Hello everyone, my name is Dr. Shabintaj. I am here to present with session 1 on digital transmission in the subject data communication for 4th semester students. With the course outcome is in order to explain the fundamentals of digital communication. Let us start with the contents. Introduction to digital transmission. Then we will be discussing digital to digital conversion, line coding, characteristics of digital signals, signal element versus data element, data rate versus signal rate. All these topics will be discussing in detail. Let us start. So all of you know, in order to send the information from source to destination or one point to another point in a computer network, the data has to be converted into one form. So this information, you have information in different forms: text, audio, your webcam data, images, all such data is there. This information need to be converted either to digital signal or analog signal for transmission. In this session, I'll be showing you the schemes, techniques that use to transmit data digitally. First, we'll discuss in this session 1 digital to digital conversion and techniques involved in which how to convert digital data to digital signal. Okay, next in the next session we'll be discussing this. It is converting analog to digital conversion and the methods associated with it. Uh, Let us quickly start with the introduction part to digital conversion. As I said, told you, data can be either digital or analog. Digital data means it is in the form of zeros and ones. Analog data means your voice, signal, means your audio, uh, webcam data, or anything can be in a analog. So the signals that represent data can be in the digital or the analog. So now we can see how to represent digital data by using digital signals. Digital data means data or binary data which involves zeros and ones. The conversion involves here there are three techniques: line coding, block coding and scrambling. Out of this we'll be discussing only line coding. Coding is always needed as part of your syllabus. I'll be discussing only the line coding. Line coding is always needed. Block coding and scrambling maybe it is optional, may or may not be needed. Now, what is line coding? It is the process of converting digital data to digital signals. So how digital data can be converted to digital signals? We'll be showing you. So we'll presume the data in the form of text, numbers, graphical images, audio, or video, any form of data can be stored. The data can also be stored in the form of memory, computer memory, in the sequence of bits, zeros and ones. So any form of data, digital data, can be converted to digital signals. So line coding converts a sequence of bits, that is zeros and ones, to a digital signal. At the sender, a digital data encoded into digital signal. You can see the sender, it encodes digital data, zeros and ones encoded into the digital signal. So 0 levels 2 here, below the time axis, 1 is nothing but above the time axis. In one form line code, there are different line coding schemes. Here, it shows one of the signal encoding schemes. So digital data zeros and ones are converted to digital signals with the help of a encoder, which is a translator, which converts the streams to signal. At the sender side, it is encoded. At the receiver side, it is decoded using the decoder, and that is converting back the digital signal to the stream of zeros and ones. So how this recreated, what are the problems encountered during this encoding? Let us see. So some of the characteristics are there. Line coding, there are different line coding schemes, and we address some of the characteristics involved in this. Signal element versus data element. So what is signal element? What is our goal in data communication? The goal in the data communication is to transmit the data, to send the data to the from sender to the receiver. A data element is what? It is the smallest entity that can represent a piece of information, anything. So that is nothing but one. So let us see, if you take a flip flop, when the flip flop is on, that can be encoded as 1. If when the flip flop is 0, then that can be encoded as off. That means a data element is the smallest entity that can represent only a small, one piece of information. This is a bit. In digital data communication, a signal element carries the data element. In other words, signal is what? It's a carrier of the data element. It carries the data element. Like analogy I would like to give here is a vehicle. Vehicle and the persons in that vehicle. So a vehicle carries the person to source to destination. Vehicle being the signal element and the person is a data element. Data elements are what we need to send. So that means that is a very important thing. Data element cannot be, it's a precious one. Whatever we want to send, that will be encoded, that will be in there embedded in the signal element. Signal elements are what we can send. Okay, data elements are what we need to send. This contrast difference you have to be very clear. Now, data elements are being carried. Yes, they are carried. They are taken from one part to one source to destination. Signal elements are the carriers. Their data elements are being carried by the signal elements. Now, let us see the difference between the comparison of signal element and data element. Now you can see this data element 1, 0, 1 is there. These three pieces of information is there, and here the signal component, there are three signals are there, and here one data element is containing the one signal element. 1:1 relation is there. Now one data element 0 is it is related to one signal element. Hence the ratio one data element per one signal element, that is data element divided by the signal element is nothing but 1. 1 by 1. One data element divided by one signal element, and the ratio is 1. So signal. Okay. Now we can see there are three pieces of information data elements 1, 0, 1, in which one data element is related to two signal elements. Two signal elements are there. One half the pulse and the so two component signal elements are there. Low to high, high to low. So you can see this. The ratio is what now? Data element divided by signal element is 1 by 2. Okay. Similarly here you can see. Now one signal element is having the two encoded with the two data elements. Now you can see that here it is 2 by 1 because two data elements and one signal element as per the comparison. Now here four data elements are encoded in one signal, three signal elements. You can see there is change of signal. So here 4 by 3. This is the difference between the signal element and the data element, which explanation is given again over here. So now you can see for every line coding scheme, we will have the value of R. Every line coding, whatever is the scheme you are using, it has the value of R. So what is that? The data rate defines what is the data rate and the signal rate. Before this, I would like to explain. I have already given an analogy. One vehicle carries one person. It is analogous to that. Now here, one person, it is carried by, say in the sense I can say you here, few persons are carried by some vehicles. Okay. Now here, two persons are carried by one vehicle. I mean one vehicle carries the two. So at the most, what is required here? What is required? You need to avoid the traffic jam. Number of vehicles you use anything, but you have to see through that the data is transmitted from source to destination without jam, without any error. So this is what analogy. Now, what is data rate? It is the number of data elements, that is number of bits sent in 1 second. How many bits you are sending? The more number of bits you send, more is the data rate, which is the unit is bits per second. The signal rate is the number of signal elements sent in 1 second. The unit for this is baud. The data rate is sometimes called as bit rate. The signal rate is also called as modulation rate, pulse rate, baud rate, all are one and the same. They are synonyms. Well, what is our aim in the data communication? Our aim is to increase the data rate while decreasing the signal rate, because when you see the road, I have told you the analogy of vehicle, transportation. So, persons being the data, vehicle being the carrier. So when the carrier is carrying the data, person, what you have to see through that? You have to minimize the number of vehicles on the road in order to avoid the traffic. Hence, you have to see through that you increase the data and while decreasing the signal. So in order to avoid the traffic jam, what you have to do? You have to use a car pooling, vehicle pooling can be used. Okay, that means with the existing number of vehicles, you can use the data element to carry, the persons to carry. Increasing the data rate increases speed of transmission. Of course, obviously, if I want to send more data, if I can send it in a less number of time, it increases speed of transmission. But at the same time, how you can increase the speed of transmission? Decreasing the signal rate, decreasing the bandwidth. The bandwidth required will be less in the case of when you transmit data fast. In our vehicle people topology analogy, we need to carry more people in fewer vehicles to prevent traffic jams. I already have told you this is the analogy. What our goal is, we have to on the road we have to use very few vehicles in order to avoid the traffic jam, pollution, all such disadvantages of you can use the less number of vehicles with carrying the more number of people. Now, there is a relationship between data rate and the signal rate. Okay, so R being the data rate. So what are C is the case. C is the case factor which varies for each case. That means here I had shown you the cases 1, 2, 3, 4. So the cases are whether it is carrying one data is being carried by the one signal element or what is N? N is a data rate. Okay, R is a it is a defined factor. What is R? R is 1 by 1 all such things. Okay, so the case factor which varies for each case. Okay, the N S being the number of signal elements. This is a S average is a signal rate. Now the relationship between and the signal rate is represented by baud. Average signal being sent is C into N multiplied by 1 by R. Okay. So as the N increases, it also increases signal rate because it's directly proportional. Now we have to see the side effect of this. The relationship depends on the value of R. Obviously, when R increases, S decreases. Okay, the data pattern, obviously, when the more data is sent, that also happens. If you have data pattern of all ones or all zeros, the signal rate may be different from data pattern of alternating zeros and ones. Obviously, when there is sequence stream of zeros and ones, the signal rate is different. When it has alternating 0 and 1, it has a varied signal rate. Now, what is bandwidth? Bandwidth is nothing but the digital signal that carries information is non-periodic. Means it is not very periodic thing. You don't know. You cannot predict. The bandwidth of non-periodic signal is continuous with a infinite range. That means it is keep on there and it is infinite. However, what you have to do, the most digital signals we encounter in the real life have a bandwidth with finite range, finite values. So the effective bandwidth is finite. You need not worry, it is not infinite, but in the real situations, it's a finite one. The baud rate, not the bit rate, determines the required. So you can see, bit rate is what? The data rate is a bit rate. Baud rate is what? Signal rate. So baud rate determines what? The bandwidth for the digital signal. So more changes in the signal means injecting more frequencies into the signal. That means there is lot of changes in the signal. That means you are changing the bandwidth. At the same time, the signal is also changed. Frequency means change, and change means frequency. You can take this as synonym. The bandwidth refers to range of frequencies used for transmitting a signal. You are transmitting a signal from sender to receiver. In the course of time, it keep on changing the frequencies. So the relationship between baud rate, that is signal rate, and the bandwidth range of frequencies given as the bandwidth, minimum bandwidth is C is equals to N into 1 by R, which is same as your yes. Yes, because signal rate and the baud rate are same. Now, when N is data rate, which is represented in bit per second, C is a case factor which varies for each case. R is previously defined. That means R ranges. So, what is the minimum bandwidth? Minimum is B min is a minimum bandwidth. Now, let us see one example for this. A signal is carrying data in which one data element is encoded as one signal element. This is the first case 1. R is equals to 1. So because 1 by 1 data element divided by 1 signal element, hence R is equals to 1. If the bit rate is 100 kilobits per second, what is the average value of the baud rate? If C is between 0 and 1. So when we substitute these values into the formula given, so since the C is between 0 and 1, we assume C is equals to 1 by 2, which is half 0.5. In between, as it says, the baud rate or signal rate is C into N into 1 by R. C is half, that is 0.5, or N is 100 kilobits per second, 100 kilo represented, and here 1 by R. R being 1, so hence it is 50k baud. Baud is the unit used to represent the signal rate. Now, another example we'll see. What is this? The maximum data rate of a channel is Nmax. Nmax is the maximum. It is defined actually in the Nyquist formula, which I will be showing in the next other class. Do you agree with this previous formula? Yes, they are both the same. We can see the signal level L levels actually can carry log 2 level bits. I will be revisiting this problem in the next when I discuss the characteristics. Okay. A signal with L levels actually can carry log L based log with base 2 bits per level. If each level corresponds to one signal element, we assume average case is C is equals to 1 by 2. Then according to the maximum Nyquist formula, 1 by C into B into R. This is nothing but 2 into B into log 2L. So this is Nyquist formula, which is equivalent to your Nyquist formula is given for the bandwidth, and here it is given by the signal rate. Both are one and the same. And this is the end of the session with the references given here. Thank you.